Today we're looking at prime and composite numbers. We're going to do a quick review of finding the lowest common multiple. We're also going to define what a prime and composite number is, and we're going to determine all of the factors of a number. Let's get started. To do a review of the lowest common multiple, you have to look at simply remembering how to find common multiples. Common multiples are simply multiples of a number that two numbers have in common. So 2 has a bunch of multiples, and you just count by 2. So all the counting's by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are multiples of 2. Similarly, 3 has a bunch of multiples. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. These are all multiples. The question is, what are the common multiples of 2 and 3? I'd like you to take a second right now. I'd like you to record this down. So I'm going to say write this down. You can hit pause here. Okay, now that you've written these things down, we can unpause. And we need to identify which ones are the common multiples. So looking down each list, I'd like you to draw an oval around the two multiples that are in common. Ideally, you wrote these down neatly and in the same line. So we can look down, and 6 and 6 are common multiples, as are 12 and 12. So are 18 and 18. Does this mean that these are the only common multiples? No, but they're the first ones that we have within the first 10 multiples of each. So looking at this, we have multiples. Now, ideally you have circled these two in your notes to identify your common multiples. And if you're going to identify the lowest common multiple, what's the lowest number that they have in common? The lowest number they have in common is 6. So right here in the 6th one, we can say the lowest. You can write that down too, please. Good. Moving ahead. New concepts. Before we look at new concepts, of course, we still have to revise some of the old stuff. When you have 2 and 14, this is, of course, an expression. As soon as we add an equation or an equal sign, it becomes an equation. The expression for this equation is 2 times 14. So this is a multiplying equation. When we're dealing with multiplying equations, we can always represent them as a tile format as below. It's 2 high and 14 across. This represents our multiplication equation. If I count them all up, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Hey, there's 28 tiles. What do you know? 2 times 14 is 28. We also need to know the parts, because this is going to come in, because as you know, I said we're going to have to find out what all of the factors of a number are. Well, we need to know what the heck a factor is. A factor are essentially the two things that multiply together to give a product. These are all the terms in a multiplication equation. Once again, I'm going to ask you to pause and write that down. Good. Now that we know what the parts are, we can move ahead. Using their tiles, we can identify what the factors are by making rectangles. Whatever we have, these are 28 tiles. That is our product. And no matter what, we have to make a clear rectangle which will represent that. So I'm going to ask you to right now go and get some tiles. Once you got your tiles, what other rectangles can you make? Full rectangles that will still use all 28 tiles. And I'm going to ask you to record that in your book as well. You've already drawn the top part, so down below that, you're going to write down factors of 28. Okay? Press pause and do that now. Good. Now that you've done that, let's actually take a look and see how well you did. To figure out what rectangles you can make, obviously, as I said, they have to be even rectangles, which means all the lines having the same amount. So let's do a very quick version of that. We know that 2 and 14 are multiples, or are factors of 28. The easy one also to do is to make a big long rectangle like that. I still have all 28 tiles, but they're in one row. So now I have 1 over here and 28 over there. So we know that 1 and 28 are factors. Are there any others? That's the question. Of course there are. We know that we can play around with some other ones, and we might work out all right. Let's see here. I haven't used all the tiles yet. Still doesn't quite work out. Oh, there we go. What does that look out like? We have 4 on this side, and we have 7 on the top. So we know that 4 and 7 are also factors. Are there any others? Well, no other factors in here. But we have identified a numerous amount of factors, and these are just using our tiles. So again, a factor is one of those things that you multiply together to get a product. We can use tiles to illustrate our factors. And that's what we did right here. Now let's look at that again for this number of tiles. We have, again, 1, 2, 3, 4, 5, 6, 7 tiles by 1. So right now we know that factors are 1 and 7, and they equal 7. But what are the other factors that are involved here? Can we make any other rectangles? Well, let's cut it in half here. That doesn't quite work. What if we did something like this? No, that still doesn't work. How about this? Hey, that works. That's a new shape. Wait a second. It's still 7 and 1. Our numbers haven't changed as factors. There is no other combination that can equate 7. So what we have here is a prime number. A prime number. A prime number has only 2 factors. Only 2 factors. All right, I'm going to write this down quickly. Factors. 1 and itself. Oh boy, that didn't work out. I'm going to get you to write that down. I know it's messy, but you guys can do that better than me. A prime number is only divisible by 1 and itself, or sorry, it only has 1 and itself as factors. So that's a prime number. Looking at other numbers, let's say 6. So if we have 6, we obviously know that in this rectangular form, it is 1 times 6 is equal to 6. What other ones are there? Well, we can group, move these around again, and do them this way. So now we have 2 and 3. So 2 times 3 is equal to 6 as well. Are there any other combinations that we can do? Here. It's the same as 2 times 3, but we have identified all of the factors here. So the factors of 6 are 1, 2, 3, and 6. When we have more than just 1 in itself as the factors, we have what's called a composite number. There we go. Composite number has more factors than 1 and itself. I'm expecting you to write that down as well. Very quick review of what we're talking about here. If I was to give you a number like 6 and say to you, list all of the factors of that number, you can simply go through the process of, I know that 1 times 6 is 6 and 2 times 3 is 6, or you can draw it out. So 1 times 6 is equal to 6, and 2 times 3 is equal to 6. There are no other factors involved, so I can simply say the factors of 6 are 1, 2, 3, and 6. Similarly, I could ask you, what are all of the factors of 13? Well, I know that 1 times 13 is equal to 13, but 2 times nothing goes into 13. 3, 6, 9, 12, 15. 3 doesn't go into 13. 4, 8, 12, 16. 4 does not. 5, 10, 15. No, that doesn't go into it. 6, 12. Nope. 7, 14. Nope. So these are the only factors of 13. So the factors of this are factors of 13 are 1 and 13. This is a prime number. And finally, we come to our homework. Here, once again, is how you set up your page. We are doing questions on page 61 of the textbook. Questions 1, A through E. Question 2, question 3, A to D. Questions 8, 11, 12, and 14. Let me know if you have any questions. Have a good time.